So in this video, I'll discuss how to determine the amount of heat that is either added or removed in order to produce a change in temperature. So when we think about heat and we think about changing temperature, that should make us think about the specific heat. Recall specific heat indicates the amount of heat that is needed to increase the temperature of 1 gram of an object by 1 degree Celsius. So based on that, you generally see it reported with the units of calories per gram degree Celsius. Recall calorie is a unit of measurement for heat or energy. Gram is your mass, degree Celsius. But you can also see it with the unit of joules per gram degree Celsius. They both tell us the same thing, the amount of energy that is needed in order to raise the temperature of 1 gram of the object by 1 degree Celsius. So specific heat values are constant values, so you don't have to go through and try to memorize values. Each substance has a different specific heat value. So for instance, if we're looking at lead, lead has a specific heat of 0.031 calories per gram degree Celsius. We can also look at iron. It has a value of 0.11 calorie per gram degree Celsius. We can look at solid water, which we call ice. It has a specific heat value of 0.490 calories per gram degree Celsius. We can also look at liquid water, and it has a specific heat value of 1.00 calorie per gram degree Celsius. Again, each substance has a different value. But what the value tells you is how much energy does it take to increase the temperature of 1 gram of this object by 1 degree Celsius. So if you notice, for instance, lead 0.031 calories per gram degree Celsius versus liquid water 1.00 calorie per gram degree Celsius, what these values tell us is that it's going to take a lot more energy to increase the temperature of liquid water than it would be to increase the temperature of lead. Same thing if we compare liquid and solid water. Those values are different. It takes a lot more energy to increase the temperature of liquid water versus ice. So if you think about an ice cube versus a cup of water, if you sit them on your kitchen counter, that ice water is going to melt a lot quicker than you would see the temperature increase in that liquid water because it takes less energy. You could also think about a swimming pool on a hot summer day. If you go outside to a swimming pool, even though it may be hot outside, when you get into that water still feels pretty cool. That's because the amount of energy that it takes to increase the temperature of that water is going to be a lot greater than other substances of similar amounts. And so, again, these are values that are constant, and these specific heat values are just giving us some insight into how much energy is going to be needed to increase the temperature. And so when we're talking about trying to determine the heat, we can utilize that specific heat as well as how much of the substance you have, as well as the temperature change in order to determine the amount of heat that's needed. Or if you know the amount of heat that has been applied to this system and you know how much was present, you know the specific heat, we can determine what the change in temperature would have been. So in other words, we have an equation that allows us to look at the amount of heat that is present. And that equation is heat is equal to your mass, so the amount of the substance that's present, times the specific heat, so how much energy it takes to increase the temperature of 1 gram of the substance by 1 degree Celsius, times the change in temperature. And this delta T simply tells us our T final minus our T initial. So what temperature did we end up at? What temperature did we begin at? So these 4 items are used in the equation. If you know any 3, you can figure out the 4th. And so we'll apply that to an example to ensure there's understanding of how we determine the amount of heat that is needed to change the temperature. And so in this example, you're asked to calculate the amount of heat transferred when a 150.0 gram block of iron metal is heated from 15.3 degrees Celsius to 67.5 degrees Celsius. So you want to figure out everything that the problem is asking you for, what does the problem give you, and then you can determine how to approach this solution. And so here, read through the problem. I'm going to go back. we're calculating the amount of heat. So that means that we do not know the heat. That's our unknown. So that's what we're trying to find out. What we do know is that we're dealing with 150.0 grams of iron. And again, I know that this is my mass based on the unit, the gram. So recall, gram is a mass measurement. And then we also know that because it's iron, specific heat values are constant. So I can look at my specific heat for iron and recall that value is 0.11 calorie per gram degrees Celsius. Again, you do not have to memorize the values. They will be provided for you. And then we can determine our change in temperature. The change in temperature, our delta T, we have the final and the initial. So we can simply determine the difference in those values. It told us that we were heating it from 15.3 degrees Celsius to 67.5. So that means that we're going to end up at the 67.5 degrees Celsius. That's our final. And we started with 15.3 degrees Celsius. That's our initial. So once we get the difference in those two values, we'll have a delta T value of 52.2 degrees Celsius. And so now we can determine the amount of heat that is needed. Because recall, our heat was equal to the mass, and we determined that to be 150.0 grams times the specific heat, 0.11 calorie per gram degree Celsius, times the change in temperature, 52.2 degrees Celsius. And so now we have everything set up. If you look, now you're going to multiply your 150 times 0.11 times 52.2. When you put that in your calculator, it's going to give you 861.3. If we look at our units, we have a gram over a gram, degrees Celsius over degrees Celsius. So our units are simply going to be calories. So that means for 150.0 grams of iron, it will take 861.3 calories to increase the temperature from 15.3 degrees Celsius to 67.5 degrees Celsius. So this is how we determine the amount of energy in the form of heat that is transferred, either added or removed, in order to result in a temperature change. We can determine whether or not it was added or removed based on how the temperature changed. An increase in temperature means that we're going to end up adding that heat. A decrease in temperature indicates a removal of heat. We can also look at the value of our heat calculation. A positive value indicates that heat was absorbed or heat was added. A negative value indicates that heat was released or it was removed. Your delta T is what will dictate whether or not your heat value is positive or negative. Again, because we're moving up to a higher temperature, we have to add heat. If we're moving to a lower temperature, so if we went from the 67.5 to the 15.3, then our final minus our initial would have been 15.3 minus 67.5. That would have given you a negative delta T value, which would have given you a negative heat value. So in that case, heat would have been removed. But we don't have that in this problem. Instead, our value increased, and the amount of heat that was needed for this increase was 861.3 calories. If I wanted to report this based on the rules of significant figures, I can do so. And I can also just round it to the nearest whole number. Remember, when using significant figures, the values used in the calculations are what you would actually use to determine how to report your answer. Based on the values that we were given, we were provided the 150.0, 15.3, 67.3. You also have to think about the last mathematical operation that was performed, and that then determines how to report your answer. So if I wanted to report it with the rules of significant figures, I would simply report it as 861 calories, but you can leave it 861.3, and that's acceptable as well. So I hope this helps. If you have any questions, please let me know. Thank you.